I welcome you all for this Java 8 series. In this video, we are going to discuss about anonymous inner class demonstration. I'm going to come up with a couple of demos on top of this anonymous inner class. In our earlier video, we already discussed about what anonymous inner class is all about and why we need to go for anonymous inner class. The reason I'm discussing about the demonstration part of an anonymous inner class is for Java 8 Lambda expression, we need the skill of anonymous inner class. So once we gain the understanding of anonymous inner class, then probably it will be easier for us to understand the flow of Java 8 Lambda expression. Here, I'm going to come up with an interface called Flyer. So I have an interface called Flyer here. And in this Flyer, I'm going to create an abstract method called fly. A very simple interface, as you can see. You have a Flyer interface and you have a method called fly, which is an abstract method. Now, coming to this implementation part of the interface, I'm going to carry a class called bird behavior. It's a class which is going to implements Flyer. So once we implement the Flyer, we need to override the fly method. So I'm going to override the fly method right now. And you can give some definition for that fly method as well. So let's say flying high. So what you can see here is I've created an interface and I have a particular class called bird behavior. And this bird behavior is implementing the Flyer interface. And we have overridden the fly method from the interface into this class called bird behavior. That's all we have done. Nothing much complicated. Now I'm going to define another class according to my application requirement. A class called zoo. Okay. In this class, I'm going to have a couple of operation, a function or a method to say. The first one is an animal operation. So inside the zoo class, we have animal operation, and I'm going to have another method called bird operation. Now, if you look at the zoo class, which contains the operation for animal category and as well as for the bird category. So there are two methods that's there defined inside this class. Now, you are going to use the bird behavior inside this bird operation. Only in the bird operation, but not in the animal operation because animals don't fly. So considering that as a constraint that birds can fly, we are going to apply the bird behavior into this bird operation. So I'm going to create an object for bird behavior, and you create an object here. So once we have done with it, you can go ahead and call the method called fly. So the observation here is you started from an interface called Flyer, which carries a fly abstract method, and the class called bird behavior is implementing the Flyer and overriding the fly method and providing the definition. Post that, we have created a zoo class. In that, I've kept two methods. One is animal operation, another one is bird operation. In my bird operation alone, I'm going to utilize the bird behavior class object, and I'm going to invoke the function called fly. I might have some other statements here. Let's say bird can eat. So this is an additional operation that's there inside the bird operation method, but the fly functionality is actually accessed via the bird behavior. Now, how do I execute this whole code. Now let's come into the anonymous demo class where I carry a main method in it, which is a entry-level function. And there I'm going to define an object for zoo. Okay. Now, by creating an object of zoo, you can call the couple of methods. One is the animal operation, another one is the bird operation. But right now, I'm going to invoke the bird operation to see what's the output of the bird operations snippet of code. So let's go ahead and execute this. Now, when I execute this, you will see that the output says flying high, which is actually the implementation of the interface called flyer. And you also have an output called bird can eat, means both are executed inside this bird operation method. But if you look at here, where you have a call to the fly method, this fly method is called on top of the bird behavior object. So this is a pretty simple code of understanding. But what I want to explain here is the concept of anonymous inner class. Now, the approach here is we are utilizing the flyer implementations only in the bird operation but not in the animal operation. So the usage of that snippet of code is going to be only bounded to the bird operation. So why can't we replace this scope of code to an anonymous inner class, because we are not going to use that functionality anywhere else other than the bird operation alone. So in that case, it's good to have an anonymous inner class representation here rather than creating a separate class and defining a name for the class and then implementing the interface and defining the overriding the functionality of the fly. So altogether, I'm going to remove this explicit class implementations, a class which implements the flyer. So I'm going to comment out this right now. I don't have a class called bird behavior at all, but still I want to make use of this fly abstract method and provide a definitions for it. But that's very closer to the bird operation. So if you see here, there is an error because we don't have a bird behavior class anymore, but we can replace this entire code like this. So I'm going to have a flyer f equals new flyer off. This is what I explained in the previous video, where I was giving you an abstract understanding of what anonymous class is all about. If you look at this code, flyer f equals new flyer, this snippet of code seems to be a little weird because we are trying to create an instance for an interface. Probably the people who are aware of the anonymous inner class can understand what I'm trying to do here. So actually I'm trying to create an anonymous inner class instance via the interface type. But actually we are not creating an instance for interface itself. So the flyer variable is actually carrying the anonymous inner class template. Using a new keyword and the name of the interface, we are ready to go ahead and define the anonymous inner class scope. So this gives the start of the anonymous inner class. And as usual, this anonymous inner class is representing the type of flyer, so it is internally implementing the flyer interface. So what we have to do, it's more similar to the bird behavior class that we already wrote, which implements a flyer, is what is technically happening, but the only difference is you don't carry a name in it. But I'm trying to create an anonymous inner class very closer to the bird operation method itself. I'm not writing the definition anywhere outside the scope of the bird operation, because the functionality of that flyer is going to be bounded only to the bird operation and you're not going to use them in anywhere else in the zoo class. So it's better to write such kind of an anonymous inner class very closer to the method, and directly you can go ahead and override your fly method here. And as usual, you can give the definitions of your fly method. So now once you create a an anonymous inner class here and represent the anonymous inner class with a variable called f of type flyer, it's very clear this anonymous inner class is implementing the flyer, and it is a rule that the class have to override the abstract method of that flyer interface. And that's what we are doing here. And how do we invoke this fly method in order to get the output of the flying high? So let's give a labeling called anonymous so that you get an understanding that this function is actually executed on top of this anonymous inner class instance. So there will be overall only one instance will get created. You cannot create multiple instances for anonymous inner class because practically it doesn't have a name in it. So when a class that doesn't have a name in it, then obviously we cannot approach to that class at a later point of time. So anonymous inner classes are instantiated automatically at the place of defining it itself. It gets instantiated, and the instantiated reference is getting stored in the variable of type flyer. So with that variable, when I say f, actually I'm denoting to the reference of that anonymous inner class. I exactly don't know what the name of that class is. So the name of the class is going to be rendered automatically with some certain standard, and now we are able to call the fly method by using f object and call the fly method. Now with this we can go ahead and execute our code. Now the labeling says flying high anonymous, and also you get the bird can eat because we already have that statement down written here in the bird operation. But if you look at here, this snippet of code is what I'm trying to conclude as an anonymous inner class. Why it is defined as an inner class? You can see a class that's defined inside another class, but it's actually not inside the class. It's been very closer to the method itself. You're writing an inner class, an anonymous inner class or anonymous class inside a method called bird operation. By this way, you can invoke the anonymous class by the reference variable called f of type flyer. So what actually happens here is, instead of giving an explicit definition like bird behavior and implementing the flyer, you can quickly go ahead and write down your implementation of an interface via the anonymous inner class structure, so that you need not invest too much of line of code in order to utilize the functionality of fly. If in case I'm going to use it in animal operation, imagine that I want this fly functionality in animal operation as well, then obviously the anonymous class structure implementation is not the right choice. Why? Because I have to replicate this piece of code again here in my animal operation, which is ideally not advisable because we are trying to implement the similar functionality of code in a redundant fashion. So how we can avoid this? We can avoid this by explicitly writing a class like bird behavior and implements flyer, and use the object of the bird behavior to invoke the fly functionality inside your animal operation and as well as inside your bird operation. So if your use case is, if the implementation is to be used in multiple scenarios, okay, in multiple functionalities, then obviously you can go for explicitly creating a class and implementing an interface. But if in case there is a scenario where you're going to use it only in a specific purpose of implementations or very specific to a particular module, then probably we can utilize the anonymous inner class representation. So by this way, overall what happens is we are avoiding the lines of code, the boilerplate code. Okay, the boilerplate code can be avoided, and you can focus straightforwardly with your implementation bounded to that particular module alone. So flyer implementation is very closer to the bird operation alone, and you can invoke the fly method. So this is and this might not be a real-time example which I'm saying, but this is just to understand how an anonymous inner class would look like. So to summarize, the structure is pretty clear. You will create an anonymous inner class by using the new keyword and the interface name. And then as usual, it looks more similar to the instantiation template. New keyword, the name of the interface, and the argument of that constructor. Now here we are trying to expand the block. This is your anonymous inner block, the open and close curly braces. And if you notice here at the end, I'm trying to apply a semicolon because this is actually a statement. So every anonymous inner class end statement have to be ended with the semicolon, right? And you override this fly method, give a definition for it, and then approach this inner class represented by one variable of type flyer itself, because the class implements the flyer interface, and you can call the functionality of fly by using the flyer f variable itself.